All right, this is sequences in series level 3B notes. Arithmetic series. So an arithmetic series is just the sum of the terms in an arithmetic sequence. So basically all those terms that would be listed out, you just add them all together and we would find the sum of that. So series can either be finite or infinite. Finite just means they end. Okay, so there is an ending point, and then infinite means they never end. So if you see those dot, dot, dots, it's going on for forever and ever, and that doesn't have an ending. So for a finite arithmetic sequence, we have this formula, S sub n. So we need n, which is the number of terms. We're going to need a1, and we're going to also need an, which is going to be our last term. So maybe you want to note that this is the last term. Okay, so let's say we wanted the sum of the even integers from 2 to 100. So we have a1, that's going to be 2. We have an, our last term, that's going to be 100. But what is n? So think about it, even integers from 2 to 100, that's half the numbers. So that means n would be 50. So we plug this into our formula. We have s sub 50, because we have 50 terms, equals n over 2, so 50 divided by 2, parentheses a1, which is 2, plus an, which is 100. Type that into a calculator, and we get that it equals, 2,550. All right, that was an easy example. Let's get one that's a little more difficult here. So same type of thing, except we have these dot, dot, dots in the middle. So we actually don't know how many terms we have. We do know what a1 is. We know that a1 is 7, and we do know that the last term, an, is 207. However, we don't know what n is. So we need to find that. We're actually going to pull something from level 2. We're going to use that explicit formula for arithmetic sequences. Okay, so what's going to happen is that's going to allow us to find n. So the explicit formula says an equals something. Well, we know that our an equals 207. That's going to equal our first term plus n minus 1 times our common difference, which it appears that we are adding 4 each time, so times positive 4. Now it's just an equation that we have to solve. So let's distribute this 4. So we would have 207 equals 7 plus 4n minus 4. So 207 equals 4n plus 3. So you subtract the 3, divide by 4, and we get that n equals 51. Okay, so n now is 51. Know that. And we want to write it in summation notation. So if you recall from level 3A, what's going to happen is we're going to have our sigma. We know our first term is when n equals 1. Now we know that our last term is the 51st. Okay, so remember the first starting term goes on the bottom, then where you end goes on the top. And now we're actually going to use this explicit formula here. Okay, that's going to go on the inside. So we would have 4n plus 3. Okay, so we had to tie something from both level 2 and 2A. Everything is building, so make sure we're keeping sharp with our material. All right, just a few more examples here. So now let's find this another sum, but now we have it in summation notation. So what we need to do is we actually need to find what A1 is. A1 is going to happen when I plug in 1 for n. So that would be 5 times 1 plus 3, which is 8. So A1 is 8. Our last term is going to be A sub 70. So I'm going to plug 70 in for n. So I'd have 5 parentheses 70 plus 3. And that gives me 353. So now that I have my first term, I have my last term, I know that n equals 70 because we're going from the numbers 1 through 70, so we have 70 terms. Now I'm going to go ahead and plug that into my formula. So I would have S sub 70 equals 70 divided by 2, parentheses 8 plus our 353. We type this into a calculator and we get 12,635. So that would be the sum of the first 70 terms given this formula. So notice something about this formula we had in summation notation in both the second example and the third example here. Okay, so what has to be true about the formula for an arithmetic sequence in summation notation? It has to be linear. Okay, no ifs, ands, or buts. It has to be linear. That means no exponents. Notice we had 5n plus 3, 4n plus 3. Hopefully you're seeing that linear pattern there. So let's look at this example. Is this arithmetic? Hopefully you're thinking, I see a square. That's not linear. That would be quadratic. So nope, this is not linear. So arithmetic series, that formula that you put in summation notation has to be linear. That's how you'll know you're working with an arithmetic series. Okay, that completes the video for level 3B.